Hello again, chem students. I'm going to go through some special terms, and at the very end I'll do some kind of medium level nomenclature problems. But this is the first part of chapter 4 in our book, Nomenclature. It's mostly memorization type stuff, so I'm going to do this little video to hopefully help you learn what terms you need to know, but I won't actually cover this part in the lecture. Okay, so the first patterns that I'm going to point out are what we call primary atoms, and they can be primary carbons or primary nitrogens. Primary means there's only one carbon attached to a center. So here's a center. I have it here as an X. So it could be a bromine or an OH or something. But there's only one carbon group right here. Okay? The carbon groups are often represented with an R. Okay, that's a very common abbreviation. It could just be a simple methyl at the end, but still there's only one carbon attached, so this is a primary carbon. If we come over and look at nitrogen, we have two possibilities. One is amines. Amine just has a simple nitrogen attached to a carbon group. And this is a primary one, so there's only one carbon attached to the nitrogen, and this would be an NH2. Something that looks sort of similar would be a primary amide. It also has an NH2. But the one carbon group that's attached is a C double bond O. And then there's something out here. So the one carbon is actually this part right here, and that makes this an amide. So the amine and the amide look a little bit alike because of the NH2, and in this case they're alike in the sense that they both have one carbon attached, so it's primary. If we go to secondary, secondary means there's two carbons attached, and so that could be two carbon groups attached to a carbon that has something else on it, or it could be two carbon groups attached to a CH2. These are both secondary carbons that we're looking at. For nitrogen, we have secondary amines, where two carbon groups are on the nitrogen, and then there would be an H. Or it could be a secondary amide, where one of the groups is the C double bond O portion, and another is just a simple carbon group with an H. That would be a secondary amide. We next have tertiary patterns. Tertiary means there's three carbon groups attached. In this case, this is a tertiary carbon. I have a different group here, bromine, amine, NH2 or something. And then it could just be a CH, and there's three carbon groups. So these are both tertiary carbons. We could have a tertiary amine, so again, just a simple nitrogen with three carbon groups attached. We could have a tertiary amide, in that one of the groups will have a C double bond O, and then the other two will be kind of simple carbon groups. So these are all tertiary patterns. There's also the possibility of a quaternary carbon. Quaternary carbon has four carbons attached, and so there would be no hydrogen at this carbon. They have to all be carbons. We could also have a quaternary nitrogen, but it wouldn't be an amine anymore, because if we had four bonds attached to the nitrogen, it would have a plus charge and be a cation. So this would be a quaternary ammonium ion. And in general, we don't see any quaternary amides. It's not that it's impossible, but it's very uncommon. We have some other names for carbons that have different numbers of hydrogen atoms on them. Okay, so the first is very simple. That's just a simple CH3, and that's called a methyl. Okay, so that's very straightforward. If there's a CH2, just the carbon that's a CH2 is a methylene. Okay, so these are common terms. And then if there's a CH, the most common term that I've ever heard used is methine. That's what they call common nomenclature. The official nomenclature would be methylidine, but I've never heard anybody use that for the simple CH. I've always heard methine. There's some other patterns that we have to be familiar with, and again, these are all pretty much memorization, so they're not hard, but you have to kind of recognize them. This is sort of an old-fashioned way of indicating a straight chain. They put a little N in front. The N stands for normal, for whatever the name is. So in this case, N-propyl, propyl means three carbons, so this would be a straight three-carbon chain. We have N-butyl, butyl means four carbons, so this is a straight four-carbon chain. N-pentyl, a straight five-carbon chain. N-hexyl, N-heptyl, and so forth. You could keep going up. From what I've read in recent years, they're trying to go away from the N pattern, but I still see it in books, so it's still around, and they have things, commercial products called N-butyl lithium and stuff like that, so the N is still there. But you wouldn't need to say it. If you're just naming your own compound, you can just say propyl, butyl, pentyl. That's okay. The iso pattern is a very common one. You might have even heard of isopropyl alcohol. So iso is this 3-carbon unit right here. 3 carbons with a branch of something in the middle. That could be a bromine, so this could be isopropyl bromide or isopropyl alcohol. Okay. Now, if you come along and stick in another carbon at the middle between whatever it is that's out here and that 3-carbon chain, then it still has the iso pattern, so it's called iso, and then you count up the total number of carbons. So in this case, it would be 4 carbons. We'd say isobutyl. If you had a CH2, there would be 5 total carbons. So you have the iso pattern, but it would be isopentyl. And you can go on up from there. Okay. A related pattern is also a secondary position. You'll notice up here this was secondary because the carbon has 2 carbons attached here. This also is a secondary carbon on a 4-carbon chain, and if you have a branch off of one of those CH2s that would be there, that would be at a secondary position, and so they call this one sec, and because there's 4 carbons, sec-butyl, sec-butyl bromide, sec-butyl lithium, things like that. Now it turns out that this is unique. Say we went to 5 carbons. If we went to 5 carbons, we could put an X there at the secondary position, so this would be 2X, but we could also put it at the third position, which would be 3X. And so they're both secondary, and it wouldn't be able to be distinguished between those two, so we don't use it there. So sec-butyl is unique. That's the only one we use it at. Okay, the tertiary pattern is general again. So this is the tertiary pattern right here. We have a carbon, and it's surrounded by three methyls, and then there's a group here, something we could put T-butyl bromide, T-butyl alcohol again. And so with 4 carbons, we would call this T-butyl. Now, if I added an extra C8 carbon in between, say this tertiary carbon and the methyl, there would be 5 total carbons. We would call it T-pentyl. And if we put another one in there, another CH2, it would be T-hexyl, and so forth. This is just a condensed version, so I just wrote the carbon, and the 3 methyls are all grouped together. So you'd have to recognize that. This is a little more difficult to see. But this is called a tertiary pattern. Okay. There's one more here, and this is a carbon that's a quaternary carbon surrounded by 4 carbons. 3 of them are methyls. And then there's a CH2 here with something. Could be a bromine. So this would be called neopentyl, this pattern right here. Neopentyl bromide, neopentyl alcohol. Right? If we came along and added an extra CH2, just as in the other cases, we'd have 5 plus this 1, that would be 6 carbons. So we have the neo pattern part here, and then to indicate there's 6 carbons, we say neohexyl, hexyl for 6, and neoheptyl. Those are possibilities. So this is all common nomenclature. You don't have to ever use this. There's proper ways, official names called IUPAC names, and you could always name it yourself, official way. But other people use these names, and so you have to be familiar with them. Now there's several pi bond patterns that we're going to have to know for our course. The ones that are very common would be vinyl something, vinyl X, vinyl bromide, vinyl chloride. The X group, whatever it is attached directly to the double bond, like this. Okay, so this is just CH2, CH, and then X. That's a vinyl group. If we stick in a CH2 between the vinyl part and the X, then we call it allyl. Allyl X, allyl bromide, allyl alcohol. If instead of a double bond we had a triple bond, then we would call it propargyl, propargyl alcohol. Now we have 2 patterns for aromatic rings that we have to know. One is the X is directly attached to the ring, and we will call that one phenyl X, phenyl bromide. Okay, something like that. And over here, if we put a CH2 between the benzene ring and the X, sort of like we did over here with the allyl pattern, then we're going to call that benzyl X, benzyl bromide, benzyl alcohol, benzylamine. Very many variations of that. Okay, so these are all patterns that you have to memorize. You can make flashcards, or I have little figures in the book that you can try and use to test yourself. Okay. This would be one of the figures that I put in the book, and something like this might be a problem on the exam, where I just go around and put all kinds of different possibilities here, and then you would have to write in the names down here. Okay. Or I might put the names and then you'd have to match the letter, something like that. But here I have A as the first one. So in this case I see the iso pattern up here. That's 3, 4, 5, 6. So I have 6 total carbons. This is the iso, so I'd say isohexyl. Okay. Here's the 4 carbon pattern with a branch at the second position. This would be sec-butyl. This would be isopropyl. This would be T-butyl. Here's the iso pattern again with 4 carbons. That would be isobutyl. So now I have the amine here, and how many carbons are on the nitrogen. So I'm looking at it as a primary, secondary, or tertiary. In this case I have a carbon, and then 2 methyls. Those are 2 more carbons. This would be a tertiary amine. This carbon is a tertiary attached to the parent chain here, and there's 5 total carbons. So this would be T-pentyl. This is the CH2 between the group and the alkene, the vinyl group. So this would be allyl. This has all the carbons around the quaternary carbon. This would be a neopentyl, but what the arrow is pointing to is just a carbon. So that would be a quaternary carbon. Here is propargyl. This is a straight chain of 1, 2, 3, 4, 5. We could say N-pentyl, or we could just say pentyl. This nitrogen only has 2 carbons attached, so this would be a secondary amine. Here's another tertiary position, 3, 4, 5, 6. This would be T-hexyl. Here's the benzene ring all by itself. This is a phenyl group, so this would be phenyl. This would be vinyl. This is a primary amine because there's only 1 carbon attached to the nitrogen. Okay, so here's 2 CH3s on the carbon in the middle. This would be isopropyl, just like this one up here, but I wrote out the atoms. 1, 2, 3, 4, 5. Here's 5 carbons with an iso. This would be isopentyl. All 3 carbons on this guy right here would make this T-butyl. And this would be a simple butyl or N-butyl. This would be benzyl. And this nitrogen has 4 groups, so it would be a quaternary ammonium ion. Okay. So I have all those answers down here. You can take a look at those, and you can go back and forth, kind of check yourself on those. Okay, so the official nomenclature is IUPAC, International Union of Pure and Applied Chemistry Nomenclature. And they come out with a book every several years, every 10, 15 years or so, of new names and recommendations. The last one that I'm aware of is the 2013 book. And there's a link you could go to here if you wanted to see sort of an online listing of those possibilities. Excuse me. So in organic chemistry, a lot of times we don't want to write out the whole structure. We just want to write part of it. And so a lot of times we'll use R to indicate just sort of a general carbon portion that we're not that interested in, just to make a distinction. If we are a little bit concerned that we want to show an aromatic ring, then we write an AR. Although if you had an aromatic ring, R might be acceptable. But if you write AR, then it has to be an aromatic ring that you're looking at. So these are just little symbols to indicate general parts that we're not real interested in. Okay, so in nomenclature, we have to be able to name the foundation of the name. And the foundation is going to be either an alkane, an alkene, or an alkyne, or a combination of those. That'll be the base name. So that's going to be the hardest part, learning all these little rules for how to do that. And then we have a whole bunch of functional groups. For us, maybe we have a little more than 15 functional groups. And most of these functional groups, well, all of them will have a prefix, and some of them, many of them, will have a suffix also. If it's a higher priority group, it might have a suffix that you would use, but you only use the suffix if it is the highest priority group. Everybody else is named as a prefix. Okay? So you got to be familiar with all of these, and I have those listed in the book, and I actually have them in this little talk as well. Okay, so there's nothing super complicated, but there's so many details that you have to practice it because it's easy to forget things and overlook things. And so I found the best way to do it is just to write them out, pencil and paper. You can't really think your way through it because you won't internalize all of those details that you need to know. All right, so in this class, what I'm going to expect you to be able to do is the name from C1 to C19. That sounds hard, but think about it. The first four are just brute force memorization. Methane, ethane, propane, butane. That's C1, C2, C3, C4. But once we get to 5, it's very familiar prefixes that you probably learned in grade school when you're looking at geometric figures, like a pentagon or a hexagon and so forth. So when we get to C5, we're going to call it pentane if it's an alkane, hexane, heptane if it's 7, octane for 8, nonane for 9, decane for 10, like a decathlon. Okay, so we've heard those terms before. Now when we go to above 10, we're going to name it sort of like the Japanese do. The Japanese say, ichi ni san yo ro roku gachi. I can't even remember now. I used to know it. Ichi ni san go roku nana hachi ku ju. Ju is 10. And then they go ju ichi, 10 1. Okay, ju ni, 10 2. And so what we're going to do in the carbon chains is we're going to use these little prefixes here that stand for numbers. Un is 1, do is 2, tri, you probably know, triathlon, 3, tetra is 4, penta is 5, and so forth. The familiar prefixes that we've seen before. We're just going to stick that in front of the 10. So if you have undecane, it's like 1 10, dodecane, 2 10, tridecane, 3 10, tetradecane, pentadecane, hexadecane, heptadecane, octadecane, nonadecane, and then they get into some weirder names like icosane. We won't worry about that. Okay, so these are kind of the foundation of the nomenclature that we're going to add to give us our official names. Now there's some stereochemistry stuff, and this is a little bit more complicated. We'll get to this more in chapter 7, but I'm just going to introduce the alkene part here. So if I have a carbon-carbon double bond, there's 2 additional bonds on each carbon. Okay, and we're going to classify the 2 groups on this carbon with priorities. If they're identical, we don't have to worry about this. But if they're different, we have to say what is higher priority and what is lower priority. 1 is higher, 2 is lower. If the 2 ones priority groups are on the same side of the double bond, we're going to call that Z. It comes from a German word, zusammen. Some people say, oh, look, it sort of has same in the middle. But how would you ever know that? Nobody even remembers the word zusammen. So what I suggest is what I overheard, Z big groups are on Z same side. Okay, si vous parlez français, if you know a little French. Okay, Z big groups are on Z same side. That works pretty well for me. I think once you learn that, then you just remember the other one is where they're opposite. So the other one, if the high priority groups are on opposite sides, we use the German word entgegen for opposite. Okay, so you'll have to be able to classify these priorities. It's very simple. The way we do the priorities is by atomic number. Okay, a higher atomic number is a higher priority. And we don't have that many atoms that we look at in organic chemistry. So we have the halogens, iodine, bromine, chlorine, sulfur. Chlorine higher than sulfur. And then phosphorus is higher than fluorine. And then fluorine's higher than oxygen, nitrogen, carbon, hydrogen. Hydrogen's actually bigger than something. That is a pair of electrons, a lone pair. So this is the priority. Remember, the higher it is over something else, like a sulfur over a fluorine. Sulfur would be 1, fluorine would be 2, whatever it happens to be. Okay, so if the 2 groups are the same, then you can switch these groups all day long. You won't even know that you switched them. So then there is no E or Z stereochemistry. That makes it a little easier if we could do that. Okay, now what we'll see in chapter 7 is that each carbon where this can happen is called a stereogenic center. Okay, because it makes different stereoisomers by switching 2 different groups or 2 different atoms. But we'll look at that more in chapter 7. All right, so these are all the functional groups that we're supposed to know, and I just put them on here just to remind you. You have many other lists that you can use to study these, but we'll just put them in here. I have them in order of priority down the line here. So we have acid, anhydride, ester, acid chloride, amide, nitrile, aldehyde, ketone, alcohol, thiol, amine, ether, thioether, also called a sulfide. Excuse me again. And this would be a halogen, like a fluoro, chloro, bromo, or iodo. N3 together is a azido, that's an azide. NO2 is a nitro. NO is a nitroso. This is just a simple carbon branch, and here we have alkenes, alkynes, and aromatics. Okay, so these are the groups that you want to be able to recognize, and you want to recognize them quickly. Okay, if you're struggling to know if it's an ester or an anhydride, you're probably going to guess wrong sometimes, like on the exam, and then you'll use the wrong nomenclature or the wrong prefix or the wrong suffix. Okay, so try and get those down so that they're really quick. You know what they are right away. Here's some confusing patterns. The reason they're confusing, seems to me, is that this has an OH and this has an OH. But this also has a C double bond O. A whole bunch of them are like that. So with the C double bond O, this is a carboxylic acid. Without it, this is an alcohol. So over here we have an acid chloride with a C double bond O, or a chloroalkane without it. Here we have an amide with the C double bond O, or an amine without it. And that can be primary, secondary, or tertiary. Remember that? And down here we have an ester with the C double bond O, or just an ROR, that would be an ether. And aldehydes and ketones look real similar, except the aldehyde has an H on one side, whereas the ketone has a carbon on both sides. The sulfur compounds are important, but not as commonly emphasized. This would be what we call a thioester. Kind of looks like the ester over here where there's an oxygen, but we put a sulfur in there. Or the thioether, kind of like the ether over here with an oxygen. And then we have the thiols, kind of like the alcohol over here. And so these are very common in biochemistry. 2 of our amino acids have these 2 groups right here. And that's 2 out of 20. That's 1/10 of our amino acids have these guys. Very crucial to life. Okay, so this is in your book. It's kind of small on this slide right here, so I don't know if you can read it all, but this is an order of priority that we have to know when we name a compound, because we put the highest priority group as a suffix at the end, so you got to know that. Up here at the top we have carboxylic acid, which is not really the top. There's groups above it, like a free radical or anion or cation, but for us this is the highest group. So we won't really have a prefix for that. Yeah, there is one. It's a number, carboxy. But we'll mainly use the oic acid suffix. So there's be some alkane, parent name. That was the methane, ethane, propane, butane, and so forth. And then oic acid. And then hydrides, okay, they look kind of like an acid, except there's an O and 2 H's taken out of the middle, so they call it anhydride without water. The prefix, we could name it, but it's pretty complicated. I don't think it's worth learning that prefix right there. But it's here if you need to know it. And so if these 2 R groups are different, then they each get a name. Alkanoic, alkanoic, and then you finish off with anhydride. If they're both the same, then you just say alkanoic one time and anhydride. Okay, esters have 2 parts also to name. They have the front part out here, which we name as a branch in front. That's the alkyl part here, alkyl, and then at the end for the ester part we call it O8 at the end. That's a suffix name. If this ester was a branch off of a higher chain, like maybe it had an acid, then we would name it as alkoxycarbonyl. Okay, acid chlorides could be named as the highest priority group. It would be oil chloride, ethanoyl chloride, something like that. Or if they're just the group right here off the side of a chain and lower priority, then they would be chlorocarbonyl. Amides have a couple of ways you can name it. You can call it carbamoyl if it's a prefix, or amido. Or if it's the high priority group, you just say amide at the end. Okay, and then C triple bond N is a nitrile group. If it's a lower priority group, we call it prefix cyano. And if it's the high priority group, we say alkane nitrile. And notice in this case, I keep the E. Okay, if the prefix starts with a vowel, we drop the E, but nitrile starts with a consonant. Aldehydes, if they're in the longest chain, we number them oxo, name them oxo. But if they're a branch off the chain, then we name them the number of the position in formal. If they're a high priority group, we say alkan al for aldehyde. Ketones also get the oxo prefix, okay, if they're in the longest chain. But when I was a student, we called them keto. So very rarely do you see that, so we will stick with oxo. So aldehyde and ketone in the chain, the parent chain is called oxo. If the ketone's the high priority group, it's alkanone. Alcohols are the OH group, and if it's a lower priority group, you give it a number and hydroxy. That is not hydroxide. Okay, so don't name it as hydroxide, that's an anion. Or it could be, if it's the high priority group, alkanol, methanol, ethanol, propanol. The SH looks a lot like the OH, it's called a thiol. And if it's a lower priority group, we can name it two ways, either number mercapto or number sulfonyl. Sulfonyl is a little more modern. I kind of like the name mercapto myself. If it's the high priority group, then it would be alkane thiol. And again, you keep the E because it starts with a consonant. Those are the only two, nitriles and thiols. If we have an amine, amines have a number of ways of being named. We'll just go with, if it's a low priority group, number amino, so 5-amino or something like that. And if it's the high priority group, then it would be number alkylamine or number alkanamine. Okay, so they're a little bit more confusing. If you have an ether, the proper way is one of them will be the main chain, and the other one would be an RO. And the RO part will be alkoxy. Okay, so say it was 3 carbons. Propoxy is what we would put. And then the thioethers, they're named as whatever, say it's 3 carbons, propyl thio, and then a number for its position. Halogens are pretty easy, fluoro, chloro, bromo, iodo. The N3 group is a little bit confusing. It's got resonance structures. I think I drew those over here so you can see the resonance structures. That's called an azido group. And then the nitro group also has resonance structures with formal charge. I drew those over here. And then NO by itself is nitroso. Okay, and then we also have to name alkenes, alkynes, and alkanes, alkenes, and alkynes. But we'll go through that in class. Okay, so a general strategy, I would suggest you do this every time you name something. And after you've done it about 10 times, it'll just be your method of naming. You got to find the highest priority group. Okay, so remember, that comes from this list right here. Okay, highest priority group. You're going to find the longest chain, continuous chain, that has that high priority group. Okay, and then you're going to number the chain so that the highest priority group gets the lowest number possible. Now, if you come back up and look at these guys, a lot of these start at position 1. This is number 1, number 1, number 1, number 1, number 1, number 1, number 1. So all of these guys are going to be the number 1 position if they are the high priority group. When we get to the ketone, it could be 2, 3, 4, 5, whatever it happens to be. Okay, now the numbers that you put on that longest chain are going to identify everything else that's there. So if there's any branches, there's going to be a number plus the name of the branch. Any substituents, a number plus a substituent prefix. And so those numbers are real important. Ideally, they're named in alphabetical order, but in my course, I do not require that because if you can name them all correctly, we won't waste the time to put it into alphabetical order. But that won't be the case for everybody. Okay, if you have a simple name, your teacher might want you to put it in alphabetical order. I usually just go down the line as I encounter them. Okay, now, double bonds and triple bonds have to go at the end. Okay, so if you have a double bond, it's not an alkane, it's an alkene. If you have a triple bond, it's not an alkane, it's an alkyne. If you have a double and a triple bond, it's an alkene-ine. And you need a number for each position of the pi bonds. If there's 2 double bonds, you're going to need 2 numbers. If there's 3 triple bonds, you're going to need 3 numbers. If the alkene has stereochemistry like E and Z, you're going to have to put E and Z in there. All right? So a typical name might look something like this. Put the stereochemistry out in front. And so far, we're just going to start with E and Z in the nomenclature topic. But when we get to stereochemistry, we'll add in something called R and S. Okay? Then you're going to have prefixes for all the different functional groups that are there. And what do we got? Maybe 15 different groups. And so you're going to have a number, number, prefix, number, prefix, number, prefix, number, prefix. Okay, and those are all the lower priority groups or some branches. Okay, then you have the parent stem name. That's the methane, ethane, propane, butane, pentane, and so forth. And then if there's any pi bonds, alkenes and alkynes, they'll go after that with a number for their position. And then whatever is the high priority group, that will go at the end. And if it's not a 1, then you'll have to put a number. But all the ones that just start at the beginning, you don't have to put a 1 there for that. Okay. So here's a fairly simple compound. It's not completely simple. There's several functional groups there. So what we need to do first is, what's the high priority group? So we go around and we say, what's this? This is an aldehyde. What is this? This is an alcohol. Oh, here's another aldehyde. What is this guy? Oh, that's the ester. Okay. What is this? Oh, that's the ether. What is this? This is the ketone. So if you can go through and identify those groups that quickly, you can probably name it pretty quickly too. So the high priority group in this compound is the ester right here. Now we have to give the lowest number to the chain that has the ester over here. This will be our number 1, 2, 3, 4, 5. So this longest chain is 5. This part of the ester over here is a branch. And we always number from the attachment point for a branch. So we have 1, 2, 3, 4. So this will be a substituent, this will be a substituent, and this will be a substituent. Okay? So our name's going to look something like this. We named the branch on the oxygen first. Okay, so it's 4 carbons, but we have to put in these branch points. So here I have a formal group because it's aldehyde as a branch. That's at the 1 position. Then 2, I have a hydroxy because it's an alcohol. And 4, because the aldehyde is in the chain, I call it oxo. And then because it's just a simple 4-carbon chain, I call it butyl. You leave a space because it's a separate word, and then you start over on this part over here. So at the 2 position, I have a methoxy. And at the 4 position, I have an oxo. And, oops, I put 2 P's. You better cross out 1 P there. And then it's a 5-carbon chain, so we would say pentan O8. O8 is the suffix for an ester. Okay? So on this group right here, our next example is a pretty complicated looking one because we have all these C double bond O's. They're not all the same. In fact, they're kind of different. So again, we have to find the highest priority group. I have some choices here. If I look down here, I see an ester. That's a pretty high priority group. I have an amine. That's not very high. These 2 carbonyls around the oxygen. This is an anhydride. This is a very high priority group, right behind the carboxylic acids. Then I have an alcohol. I have a carbonyl with carbon on each side. That's a ketone. And then a carbonyl with a hydrogen on one side. That's an aldehyde. So our highest priority group is the anhydride right here. We're going to number each side separately. 1 from the point of attachment here. 1, 2, 3, 4, 5. 1, 2, 3, 4. Except we're not going to number this one because it's going to be a whole ester unit right here. Okay. So then I'll use those numbers. I'll say a 2 hydroxy and a 3 oxo and then a 5 oxo. So it'll be 3, 5 dioxo. Okay. So this is going to look something like this. Let's look at this side first. We have 2 hydroxy, we have a 3 oxo and a 5 oxo, so we lump those together since they have the same name, 3,5 dioxo. Since it's 5 carbons, we use pent. There's no double bond, so it's a pentan, and then the suffix is oic for acids and for anhydrides. Then we come over and name the other side, just sort of like it. 2, we have an amino group. 3, now we have to be a little careful because this whole thing is the ester. I can't just name this part here, the whole thing. So 3, and then I have a methoxy carbonyl. All right, so that's a funny one that you got to learn, but you know, you'll learn it. It's not that hard. So 2 amino, 3 methoxy carbonyl, propanoic. And since it's an anhydride, we say anhydride. And there's a little space between each of those words. Okay, I think I have one more example. Oh, here's I'm just saying on the esters to count the ester carbons. So a lot of times I see students leave this 1 off. They start numbering 1 over here instead of where the carbonyl group is. So I just wanted to make a point here to make sure that you number 1 at the carbonyl. And then this is the branch on the ester. This would come first. So if I go 1, 2, 2, I have a methoxy. All right, then I go 1, 2, 3, 4, 4, I have a hydroxy. So this would be 2 methoxy ethyl, 2 carbons, space, 4 hydroxy, and then butan O8, the ending for an ester. Okay. So this is an anhydride, this is an ester, but notice we start all of those chains at the carbonyl, the number 1 guy. Okay, I think this is our last example here. So again, I'm looking, this is an amine, here's an amide. Anything that has that double bond O is going to be towards the top in priority. I have an alcohol again, and then I have a nitrile. So nitrile is pretty high, but it's not as high as these guys with the double bond O. So in this case, my longest chain, 1, 2, 3, 4, is this part right here. And then a nitrogen has 2 branches. So this is actually a tertiary amine. This is a really simple branch. 1 carbon is methyl. But this one we're going to have to number. 1, 2, 3. And then this is a cyano group. So I'll have a 1, 2 hydroxy, 3 cyano, and 3 carbons with no double bond or triple bond would be a propyl. Okay, and then I have a methyl. And for these guys, I put an N in front to meaning that they are on the nitrogen. And then I come over to this side, and I have to name this. This is at the 2 position. I have an amino. But the amino has 2 groups, so I'm going to say an N-ethyl and an N-methyl. And for these guys, I'll put it in parentheses and a number for the longest chain here. So that's going to look something like this. Okay, so we come out N for this part, 2 hydroxy, 3 cyano, in parentheses, because they have their own numbers. And then I go N-methyl, right here. And then I say 2, because now I'm naming the other side, 2 N-methyl, I'm sorry, 2 N-ethyl, N-methyl amino. N-ethyl, N-methyl amino. And that's in parentheses because the N's are separate from the 2. And then it's 4 carbons long, so it's butane, and drop the E, add amide. That's the suffix for an amide, butanamide. Okay, and so I just wanted to put in a nitrile just to point out again that we don't drop the E on nitriles or thiols because they begin with consonants. So I have a 1, 2, 3, and then this group here, amino group. So this must be a propane nitrile. 3 amino propane nitrile. Okay, and so this is just a quick introduction. Mainly this is for the common terms at the very start. I just wanted to add a few little simple examples of nomenclature to look at after we go through the chapter. Okay, good luck.